So before we move on to actually looking at some of these plots and interpreting them, it's important for us to talk a little bit about our data first and categorizing these data in a couple of different ways. Now, the first categorization that we're going to make with our data is we're going to need to break it into two different categories. The first of those categories is going to be numerical in nature, and the second is going to be categorical, right? And if we think about numerical data, right, we're talking about anything dealing with numbers, right? So this could be, the number of wheels on a car, the amount of money in a bank account, someone's height measured in centimeters, right? Anytime that we're talking about numbers, we're talking about numerical data. Now, categorical data, as the name suggests, is talking about any time that we're talking about categories, right? So I think before in some previous lesson, we talked about the different colors of a car, right? Red, blue, green, white, silver, black, right? Those are different categories. That's a categorical data set, different colors of a car. T-shirt sizes, small, medium, large, extra large. Again, categorical data, right? So any data that is non-numerical is inherently categorical, right? So that is the first sort of distinction or way that we need to categorize our data. And when we're categorizing this data, that's going to inform what kind of analysis we can do, what type of visualizations we're going to make. It's really important for a number of reasons. Now, once we got our data sorted into either numerical or categorical, right, there are some more categorizations in each of these subgroups that we need to make. Let's first look at numerical. There are two major distinctions that we need to make. The first is discrete, and the second is continuous, right? We have to consider our data to be either discrete in its nature or continuous in its nature. If we're looking at discrete data, right, let's think about an example of this. And again, I'm just going to draw a number line. And I'm going to start here at 0, 2, 4, 6. That looks like a 0 and 8. And I'm going to say this number line is number of cylinders in engine, right? Now, if I consider the possible values that I could have, right, those possible values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, right? Theoretically, one could make a very, very large engine and come up with some large value. So I have this data set, right? And I have a limited number of data points that my data could be, right? That's to say that there is no engine that has 5.5 cylinders, right? That is not a possible outcome, right? So I have these discrete points, right, of possible outcomes, right? And in between those points, right, are these gaps, right, where there is no possible outcome, right? And that is the nature of discrete data. Now, conversely, continuous data is exactly the opposite of that, right? So again, if I have some number line, and again, I'm going to start at 0, and this time I'm going to end at 60, and I'm going to say this is inches. Actually, let's say height measured in inches, right? Now, so long as I have some tool where I can measure with infinite precision, the possible values are anything, technically, right, anywhere above this value 0, right? And there are no gaps in the possible outcome, right? What this is called, this interval, is actually a continuum, right? There are no gaps. The possible outcomes are continuous, right? Let's say I even had two outcomes, right? If I ever have two outcomes, I can always add a third in between them, right? And then if I wanted to add a fourth in between those, right, I could add in between those. I could do this infinitely, right? I could add more and more data points. There are an infinite, right? We can say there are an infinite number of possible outcomes. So long as we have a instrument that is capable of measuring to infinite precision, right? So that's the difference between discrete and continuous. Now, when we go to categorical data, right, there's one more thing that we can say about categorical data, and we can see that it is either ordinal or we can say it is non-ordinal in nature, right? And when I say ordinal, what I mean is it has an inherent order, right? So, for example, right, I said this earlier, I think, t-shirt sizes, right? We have from small to extra large, right? There's an inherent order in this data set. This is an ordinal data set, right? If I think about numerical data, we can say that this is always ordinal, right? We know that our number line is in its nature ordinal, right? So we can say all numerical data is ordinal, but that's not necessarily the case for categorical data, right? If maybe I have a category, maybe if I'm collecting data about some individuals and my categories are employee, manager, client, sales lead, and what's another type of client? Maybe a vendor, right? Someone who sells my business something, right? There is no inherent order to these different categories of people, right? So these are sort of the categories of data that are important to know. These are going to help us inform not only when we're plotting, but also when we're doing analysis. And when we start to talk a little bit more about inferential statistics and probability distributions, it's going to be really important for us to be able to identify, is this data numerical or categorical? If it's numerical, is it discrete or is it continuous? If it's categorical, is it ordinal? Is it non-ordinal? Right? The ability to be able to decipher these things from a data set is really important to do. So, is just an important sidebar here for us to take before we actually start looking at interpreting these plots. Because when we talk about these plots, we're going to be talking about which type of data each of these plots is best to use. So that's it for this video. In our next video, we're going to start to talk about bar plots a little bit, how to interpret them, how to use them, and we're going to run through all of these plots, bar plots, pie charts, histograms, some of the common stuff before we move into set theory. So make sure to hit like and subscribe, and we will see you over in the next video.